Hello everyone. So welcoming you in the new session of Propositional Logic and Hardware. In the last video, we finished the questions, the unsolved exercise questions related to truth table. In this video, we will cover the questions related to logic circuit. So let us start with the question. So here one expression is given here, the Boolean expression, and we just have to draw the logic circuit for the same. So it is xy plus x bar, I'll give it now, x y bar and plus x bar z. Okay, so this is the expression and Boolean expression. So you know very well, let me remind you again. So in between these all we have a dot sign. So dot is for and, okay, and plus is for or. So the symbolic diagram also should be clear to you. If you are not clear with the basic gates and the diagram of all those stuff, so you can check the previous videos. Okay, so we have xy here. So two inputs are there, xy, and here we have xz. Okay, so let us start drawing with you can see we have one and here, one and here, one and here. So we will draw the first AND gate. This is for the first one, then this is for the second one, and this is for the third one. Okay, now the inputs are x and y. So this is x and this is y. Now you can see we have x, y bar. Bar is not. Okay, so here you will give x and then you will draw one NOT gate, and this is this side, on the left hand side it is y, and here it will become y bar. Then you have x bar z. So again the same thing, you can draw one NOT gate here. This is x this side, and this side you have x bar, and the second one is z. This is AND gate, so you can write down properly, and here also it is and then here also it is AND. When you will take out the outputs from the AND gate, it will give you xy. Okay, this will give you x y bar, and this will give you x bar z. Okay, so you can join all them together, and here in between you have plus, which is OR gate. So draw one OR gate here, and by this you will be able to join all the three. So this is the final one, the final output. Okay, so this is the solution of the first part of this question 30, first part. Okay, moving to the next part. So this is also you can see the same type of question. You have to remember the same thing. Here you have now the dot, and here in between you have the plus sign. So that means the OR operator will come here, right? And we will join them together with the help of AND. So one OR operator, this one, this one, this one. So three are there. So I'm just drawing them together, one OR and one more OR, right? So yes. Now when you will, output will come out, and you can check the inputs. It is A, B, A, B. Okay, the second one is what? It is B plus C, and this is C bar plus D, C bar plus A bar. Okay, so now we have B plus C. So this is B and this is C. Now C bar, the same thing. So here you have the input which is C and will be converted into C bar, and then you have the input is A, and that A will be converted into A bar. So when you will take the output of this, this is A plus B, the output of this is B plus C, and here you have C bar plus A bar. Now you can join them together. Okay, and this time we have a dot here which is for the AND gate, and AND here, and this is the final output. Okay, so yes, this is the final output, right? So again I am repeating, these type of questions are not tough and actually important also for the exam point of view, but yeah, you will feel a little difficulty if you are not clear with the gates. So the diagram, the symbolic diagram should be clear to you. Now if you will go for the proper expression, it is A bar B plus BC. So again you have a dot here, so AND. Okay, so two AND will come. So this is a little, you know, less complex. So here we have the AND, here also we have one AND gate, and this is A bar. So please write the NOT gate which will convert this A input to A bar and directly to B. Then you have a BC. So this is B and this is C, and when the output will come, so this time you have to join them with the help of OR gate, and you are done. If you want to write it properly, please don't forget to write it down. and if the expression is small, you can just mention it here also, or the output is also fine. Okay, so this is the third part of the logic circuit diagram. And now we will move to the last part, which is given under question number 4. So we have XYZ. This is the printing problem only. So this X also we will consider in small only, XYZ, and then you have X bar, Y, Z bar. Okay, so again go for it. You have dot here. So and so this time also we have two only, one and I'm just making a little big because the inputs are 3. So here I am writing in between the space and then X, this is Y, and this is Z. Please mention X, Y, Z, and the output will be X, Y, Z. Now we have X bar, so just draw one NOT gate here. So it will convert this X to X bar, and direct is Y, and then again it will convert this Z to Z bar, and then the final output will be X bar, Y, Z bar. Now you please join them together with the help of OR gate. Here you have OR, and this is the final output, which is X, Y, Z plus X bar, Y, Z bar. Okay, so we are done with question number 30 with all the 4 parts. I hope you are clear with all this. Okay, so now the next one is, here you have to work with the table also, in draw or design a circuit 3 input which gives a high input when there is even number of low inputs. So first we have to go with the table. So truth table is here. As you can see, they are asking you to go for 3 inputs, right? So which gives a high input when there is even number of low inputs. So first let us fill the basic values for 3 inputs. So in case of 3 inputs, we have to start with 4 zeros and 4 ones, right? You remember I told you this one in the earlier sessions also. So if you are not clear with how can we fill the values for 2 inputs or for 3 inputs, you please go the previous the first session of this one. So well, I am writing it here 4 zeros, okay, and then 4 ones, then 2 zeros, 2 1, 2 zeros, and 2 1. Then we have 0 1, 0 1, 0 1, and 0 1. Now what they are saying, so this is for 3 inputs. So when there is even number of low inputs, so low is what? 0 value. So even number of 0, that means you have to check, you have to count here even number of zeros. Let me write it down here. Even number of zeros. So here you please count here 1, 2, 3. 3 are there, so this is odd. Okay, and here 2 are there, so even. Then here we have 2 even. Then here we have 1 odd. Then 2 even. Then 1 odd. Then 1 odd. And here we don't have, so it will consider as odd. So here you can see these 3 are for even. So for this we have to draw the circuit diagram. So please write down the expression for this even. So for 0 it is bar, and for 1 it is without bar. So X bar, Y bar, Z. We have X bar, Y bar, and Z. Now you please check X bar, Y, Z bar. X bar, Y, Z bar. Okay, and this one you can ignore. For even again, for 1 it is X, and for zeros it is bar. So we have X, Y bar, and Z bar. So well, these 3 expressions are there. So please check it again. It is X bar, Y bar, Z, X bar, Y, Z bar, and X, Y bar, Z bar. So moving to the next, here I have already written 3 statements. One statement is there in which all the 3 functions are written. So we have X, Y, Z. So here it will be X bar, Y bar, and Z. Okay, so let us go for it. So here we have X bar, Y bar, and Z. Then you have X bar, Y, Z bar, then X, Y bar, Z bar. So for this we actually have to draw one circuit. So again the same thing, for dot it is and and for plus it is OR, and for bar, this is bar, we have not, right? So draw this. So for all the three you can see AND gates are required. Dot, one AND gate here, one. So I'm just drawing first 3 AND gates. Okay, then 3 inputs are there. 1, 2, 3. For second also 1, 2, 3. For third also 1, 2, 3. Then here you have a bar for X. So this is bar. This side X, X bar. Then Y, Y bar. And then Z. This is and you have and, right? Then again X, Y, Z, X, Y, Z, X bar, so give one knot, X bar, Y, Z bar, okay? Then X, Y bar, and then Z bar. So now take out the input for all these. So this will be X bar, Y bar, Z, X bar, Y, Z bar, X, Y bar, Z bar. Now join them together and then you have OR. You can see the plus sign is there for joining this OR, and then you have the output. So this is a little tricky question because the expression also we only have to create the expression, right? So that's all about this 31 question. Moving to the next question, which is also based on the same, in which also the condition is given. Design a circuit with 3 inputs which gives a high input only when there is even number of low or high inputs. Okay, even number of low or high. So you have to count either 0 is the counting of 0 should be even, or the counting of 1 should be even. So let us start by filling this 0, 0. So 4 zeros, 4, 1, 2, 3, 4. Then 2 zeros, 2, 1, 2, 0, 2, 1. And the last is 0, 1, 0, 1, 0, 1 and 0, 1. Now even number of 0 are or 1 and or 1. Okay. So here you can see if you are counting for 0 because 1 is not there. So this is for odd. So this one is not even. So you will write odd. Okay. Now here you check even number of zeros are there. So we will write even. Here also even number of zeros. So even. In this you have even number of 1. So even. Then even number of 0. Even. Here also 2 ones. Even. Then even number of ones, even, and then odd number of ones, so odd. So you have to write the expression for these in a 1. So this one 0, 0 with bar and 1 for without bar. So you have X, okay, then you have bar, Y bar, Z. This one is X bar, Y, Z bar. Then this one is X bar, Y, Z. Then this one is X, Y bar, Z bar. Then this is X, Y bar, Z. Then X, Y and Z bar. Okay, these two are not required. So again you can check if you will go with the values here. So here you can see for 0 I have written what? Bar. So X bar, Y bar, Z is the first term. X bar, Y, Z bar, X bar, Y, Z, X, Y bar, Z bar, X, Y bar, Z, and X, Y, Z bar. And now they are asking you to go for the circuit of this one. So go for it. If you will go for the logic circuit, you should be clear with the terms. So let me write down the terms first. So this will become a little, complex structure. So I'm just saving my space by writing the terms here. This is X bar, Y bar, Z. Then the second was X bar, Y, Z bar. Then the third one is X bar, Y, Z. Then next is X, Y bar, Z bar. Next is X, Y bar, Z. And the last I'm writing upside. It is X, Y, Z bar. So 1, 2, 3, 4, 5, 6 are there. So 6 AND gate. This is 1, 2, 3, 4, 5 and 6. Okay. Then 3 inputs. 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3. In between you please give and, 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 and gate, and gate. Bar you will just add one not. So X bar, Y bar. So this is X bar, Y bar, X, Y, Z. Then X bar and Z bar. So X and Z. So this is X, Y, Z bar, X bar, Y, Z bar. Then X bar. So only the NOT gate is here. X, Y and Z. Then X, Y bar. So Y and NOT gate. And then Z NOT gate. Okay. So then you have X, Y bar, Z. So X, Y bar, Y and X, Y bar, Z. So Z like that. And then X bar, X, Y, Z bar. Okay. So X, Y and Z bar. Z for Z bar, it is NOT gate. Now you take out the input, output from all the 6 gates. So if you will start from the first one, this will be X bar, Y bar, Z. X bar, Y, Z bar, X bar, Y, Z, X, Y bar, Z bar, X, Y bar, Z, X, Y, Z bar. Now take out all these and we have to just make them closer to each other so that easily we can draw one OR gate and we can join all these together. So this is a big OR gate here and you can just draw it properly. When you will draw it on a paper, you will be able to draw it in a proper way, and this is the final output. Okay, so this is looking like a little lengthy as such, but it is not tough. Okay, it is easy only. So you have to be you have to be clear with the symbolic diagrams, okay, and the output. So next is one more logic circuit is there, but I was unable to type the bar thing. So I left the bar at that time when I was preparing this. Now let me write it down. This is question number 33 as per your book. So we have XY plus X bar and Y bar, okay. So easy only, you can, you have to draw the logic circuit. So just draw one AND gate here and then one more AND gate here, and here I'm writing AND, here I'm writing and 2 inputs we have X and Y. So one more is you can give bar here, so X, and then one more bar here, so Y. Here it will be X bar, Y bar. When you will check the output, this will be XY and this will be X bar dot Y bar. Now you can join them together and you can add with OR gate. So this is your OR gate and you are done. This is your output you can write, or you can write the word. You can write this expression also, because expression is also a little small only, so you can manage. So next to this we have one more expression given, and again the same thing, the logic gate for 4 inputs, okay. So well, again I'm just drawing the same 4 AND gate, 1 more 2, 1 more 3 and 1 more 4, okay. And then 4 inputs, 1, 2, 3, 4. Let me check if any bar is given here. Yes, bars are there. It is A bar, B bar, C bar, D. Then A, B bar, C bar, D. Then A, B, C bar, D, and A, B, C, D bar. So you please write it down. It is AND gate. We have AND, we have AND again, and we have AND. Now 4 inputs are there for each. So you can draw 4 lines. If you want to make in between the NOT gate, so you can just draw the NOT gate first. I am just drawing it here itself. So A, B and C are bars. A, B, C and D. So when you will take the output, it is A bar, B bar, C bar, D. Now A is like that only, B bar. So for B you give NOT gate, B bar, Then for C also you give one gate C and then D. So this will become A, B bar, C bar and D. Now we have A here, then we have B here and C bar. So this is C and bar and then D. So here you have A, B, C bar and D. And then you have A, B, C and then bar. Okay, so this is D bar. So it is A, B, C and D bar. Now you can join them together just to reduce the space. I'm just folding these lines and then join it with OR gate. So this is your OR gate and this is your final output. So well, we finished all the logic circuit based questions. So I hope you are clear with all these questions, because we took some good examples and we solved the unsolved questions also. So I hope you are clear with all those stuff, but still if you have any doubt, please don't forget to drop a message. And just to understand this video, you have to be clear with the previous content. So if you are not done with that till now, so I'll share the link in the description box and you can just check it out. If you like the video, please don't forget to share with your friends, with your family, and please don't forget to subscribe the channel. Thank you so much. Bye.